Okay, guys, so in most population distributions, our shape is actually not normal. So what we're going to talk about in this video is what would the shape of a sampling distribution be if the shape of the population distribution is not normal. So, not quite there yet. So, as the sample size increases, the sampling distribution um, of your sample mean will change its shape. So it's going to start to look like it's a normal distribution. So when the sample size is large enough, the sampling distribution of your sample mean um, is going to be very close to normal. So this is always going to be true no matter what shape the population distribution has. So even if the population distribution is not normal, the sampling distribution of your sample mean can look normal if you have enough samples. And we'll talk about too what the normal or large sample condition is. So this will always be true as long as the population has a finite standard deviation. So we've talked a lot about that idea. So okay, so what is the shape of a sampling distribution of x? That should say x bar when the population distribution isn't normal. So we're going to draw an SRS of size n from any population with mean mu and finite standard deviation. The central limit theorem says that when n is large, the sampling distribution of the sample mean x bar is apparently normal. So so the central limit theorem says that even though the population distribution may not be normal, your sampling distribution of your sample mean will be normal as long as you have a finite standard deviation and as long as your sample size is big enough. So how large a sample size is needed for the sampling distribution to be close to normal depends on the shape of the population distribution. More observations are required if the population distribution is very far from normal. So let's talk about the normal or large sample condition for sample means. So if the population distribution is normal, then so is the sampling distribution of x bar. This is true no matter what the sample size n is. But if the sampling distribution is not normal, the central limit theorem tells us that the sampling distribution of x bar will be approximately normal in most cases as long as the sample size is greater than or equal to 30. Quick example and then we're done. So your company has a contract to perform preventative maintenance on thousands of air conditioning units in a large city. Based on service records from the past year, the time in hours that a technician requires to complete preventative maintenance on an air conditioner follows the distribution that is strongly right skewed and whose most likely outcomes are close to zero. The mean time is 1 hour, and the standard deviation of your population is 1. In the coming week, your company will service an SRS of 70 air conditioning units in the city. You plan to budget an average of 1.1 hours per unit for a technician to complete the work. What is the probability that the average maintenance time X for 70 units exceeds 1.1 hours? Okay, so let's take a look. So I think you guys have this in your notes, so you can just refer back to that to do the work. Okay, so let's just put some stuff down. So we know that the mean of our sample is just going to be the mean of our population, so that would just be 1 hour. our standard deviation of our sample mean is going to be our standard deviation over the square root of n. So that was 1. They told that to us, and 70. Is it 70? Yep, they took an SRS of 70 air conditioning units. So that's going to give us 0.12 for our standard deviation. So we know that n is equal to 70, which is definitely greater than or equal to 30. And so we can say that it's approximately normal. And so because it's approximately normal, I can use a normal distribution with a mean of 1 and a standard deviation of 0.12 for my probability. We are looking for the probability that the sample mean will be greater than 1.1 hours. And so we're going to do norm CDF. Lower boundary will be 1.11. I always use 999. Some people use 1,000. Mean, standard deviation, and it would be about 0.2023. So I think we could say about, that's an important word, about 20% chance that the techs will not complete the work on the air conditionings in the budgeted time. And that's it for this video. Enjoy the rest of your vacation. Hope you're working on your take-home assessment.